microclimates, and this is one that's really important for when we start looking at microclimates, and we're selling different parts of a house. Now, for example, we did our business. We did a lot of whole house remodels. We did just room additions, and we also did new construction. For example, if we were going to get into is room additions, for example, and they want to put in a four-season porch. Well, it's a forced air system. Putting the header system in, I can't run so I'll run electric system out there. That is now a microclimate within the house. If we look at this house here, how many microclimates do we see? We have a room here with a wood burning fireplace. We know it's sucking air out of the house, and it's also dry heat it's putting in. We also have a laundry room here. Well, that's also, with the higher humidity levels, it's going to affect the kitchen floor. So knowing on where you're going on application on a house, it's also important to know on what microclimates are going to be within that resident, as well as coastal, like I said, like in San Francisco. High-rise condominiums. What we must understand is, for example, the higher you go in a building, the less the humidity will be. And also, the higher you go, the temperature will be higher. Like my son, we live out in the country. He didn't like country living. He wanted to be down where all the action is, so he bought a place down in the cities. And he kept saying, Dad, you know, I'm up on the 14th floor. I got thermostat shut off in the winter, and it's still 78 degrees in my building. That's because you're getting a stack effect. All the heat's rising upward. So in here, it's the same thing, that you're going to find that the humidity is also going to be drier at the penthouse than you will on the 5th floor. So when you start looking at parameters of a manufacturer, the manufacturer's floor will probably work for the first 5 to 8 floors. But the higher you go in these buildings, the drier it's going to become. So the awareness of knowing of what's going to happen to those floors to ensure that you're not going to get your splits and checks involved. Or maybe we're a floating floor system where then you'll see that it's contracted so much we're seeing shrinkage along the baseboards. This is where it's important to know on how that these microclimates will affect the floor that you're selling. Just a little simple thing when you start looking at relative humidity and dry air. For example, here when you look at warmer air, you look at the water vapor here, and then as the colder it gets, you'll find where the cooler the air, the less capacity it'll hold water. So when we take, for example, here a relative humidity, and we're doing dynamics, and outside conditions are 10 degrees and 70% relative humidity. And people will usually say, I don't need a humidifier in the winter because it's always 70%, 80%. When we take that same air at 70% and look at the water vapor here, now we're going to take, nothing's changed. All we did is we heated the air to 70 degrees, and the water vapor did not change, but now the indoor relative humidity conditions dropped to 6% relative humidity. This happens on a daily cycle. So showing on fluctuate, if that fluctuates from 10 degrees outside to 30 degrees, back down to 0 and back up, you're going to see the cycling of the same thing when it's coming to your relative humidity. So when you start looking at just a simple chart, for example, like here we have a relative humidity and dry air, recommendation levels for humidity. When we start asking ourselves, this is off of April air, and so if you have on here is doing a difference of 6% to 30%, why is the wood floor getting splits? We're ended up at 20 degrees. At 20 degrees outside, we can furnish, on a standard window, we can furnish 35% relative humidity without a problem. When we get into as far as some, for example, like how many of us have taken our kids and you've gone to the pool at a hotel and they got the big, in the hotel there, and they got, wow, it's in the middle of winter, but there's no condensation on the windows. If we look at the glass and how glass design is, you look at your glass design, here you got your single pane, and you'll have here that at 10% inside relative humidity, you're going to have condensation at an outside temperature of 10 degrees. If we take a double pane glass, you're going to see here is your swing, and going up here is at 10 below, and you'd have your 20% relative humidity. So you get back to here is a triple pane. We can go as high as almost in 45% relative humidity, inside relative humidity at 20 below. That's how the swimming pools do it around. They've got triple pane glass in those hotels. Here we talked briefly before about solutions. Here you have just a grand piano, typical humidifier runs 500 to 800 to have one mounted permanently in the piano. Any musician will tell you they need it. It simply is. If a piano changes, for example, if the RH goes down, so will the pitch in your piano. If the RH goes up, so will the pitch in your piano. So they want steady to keep that piano tuned around the house and keep their music. So really, for 800 bucks, they're preserving their piece of art. Same difference that you look at as far as an evaporative type system here, about $500 to $800. And if you're doing the wet environments, like in doing on coastal regions, looking at dehumidification or doing whole house ventilation systems, they're between $500 and $1,700, depending on the system you put in. But it's important to understand, if we can control it for the piano, I can also control it for my wood floor.